Okay, today we shall be developing the error correction model. We shall be developing the error correction model, meaning that ECM model. So we shall be developing the error correction model today. And here we have three variables such as GDP, LR, and M. So we have three variables. One is GDP. What is GDP? Gross domestic product. That is our first variable. Second variable is all LR. What is LR? Lending rate by the bank. Lending rate by the bank. So that is our second variable. And the third variable is M. What is M? Money supply. M is money supply. That is our third variable. So one is gross domestic product, lending rate, and money supply. So we have these three variables in the model. So here the variables are like this. I can open all the variables at a time. I'm opening all at a time. Just 1 minute. So I'm opening all the three variables as a group. Okay. So these are the variables from 1960 until 2010. 1960 until 2010. So that is our variables, right? That is our data. That is our variables, right, for this model. And here what is happening here is here we assume that, and here we assume that our three variables such as GDP, M, and LR are integrated of same order. We assume that our three variables such as GDP, M, and LR are integrated of same order, meaning that these variables will become stationary suppose after first difference. Meaning that these variables will become stationary, suppose after first difference. As a result, we can run the Johansen test of cointegration because Johansen test of cointegration the number one condition that variables must be non-stationary or unit root at level, but variables must be non-stationary or unit root at level, but after converting variables into, suppose, first differenced, but after converting variables into suppose first difference, they will become stationary, meaning that there is no unit root. So what is the condition of Johansen test of cointegration? The first condition is that variables must be non-stationary at level, but after converting variables, suppose into first difference, they will become stationary. Only then we can run the Johansen test of cointegration. Okay, and here suppose we assume that our three variables such as GDP, LR and M, they become stationary after first difference. Suppose we assume, without checking, without testing. So now we can run the Johansen test of cointegration. So I go to quick, then I go to group statistics, then I go to Johansen test of cointegrations, and here I put our all variables LR, GDP and M. So here LR is the lending rate, GDP is the gross domestic product, and M is the money supply. Okay, and we assume that all the three variables are non-stationary at level. That means here they are non-stationary, meaning that they have unit root, but after converting all the variables, all these variables, they will become stationary. That we assume, and only then we can run the Johansen test of cointegrations. Okay, so here I press OK, and here I choose 3, and here I assume that lag 2 should be optimal for this system equation or Johansen test of cointegration that I assume, or lag selection criteria is asking me to take lag 2. So that is why I have taken lag 2. That is why lag 2 is chosen. So then after choosing lag 2, then I press OK. So the result is coming up gradually. You can see the results. The Johansen test result has come up, that you can see from here. Right. So these are our variables, and here I have chosen lag 2, and this is Johansen test of cointegration. And here we have two tests. One is trace statistics and one is maximum eigenvalue test. We have two tests. Okay, so out of two tests, first I check trace statistics. That I check first. Okay, so first I check that trace statistics, and what is the result is here. Okay, and here, and what is our null hypothesis? The null hypothesis is, so what is the null hypothesis? So here the null hypothesis is I'm putting here, the null is there is no co-integrations, or there is no co-integrations. That is the null hypothesis. And what is the alternative hypothesis? Alternative is there is co-integration. There is there is co-integrations. Okay. So so this is the hypothesis. So far I can tell. Okay, I just double check what is the hypothesis is here. Hypothesis actually mentioned here the co-integrations. Okay, so so that is the I'm putting it here. I come back to that place again. I come back here. Just come back. So then there is no co-integration. That is the null hypothesis. And alternative, that there is co-integration among variables. So there is no co-integration among GDP, LR, and what? GDP, LR, and M. And there is co-integration among GDP, LR, and M, right? That is the alternative hypothesis. Okay, then what happens from here? You can see from here. Okay. Okay, so first I check that trace statistics, right? Trace statistics and the outcome. What is the result? Okay, the first result is that is the none. What is none? None means there is no co-integration. That is the first hypothesis. None. There is no co-integration. So actually hypotheses are already given here, right? So that here I can delete this one. I can delete this one. This thing is not needed because hypothesis is already given here. So it is already given here. So I can check the thing from here. Okay. So so the first hypothesis is this one. None. You can see hypothesized value none. None means there is no co-integration among the variables, or there is no co-integration among three variables. So that is the null hypothesis. So and the thing is that the trace statistics is how much? Trace statistics is 42.85. That is the trace statistics. And critical value is how much? Critical value is coming up how much? You can see from here, 29.779. Okay. So the statistics is 42.85, but critical value is 29.79, meaning that trace statistics is more than critical value, meaning that we can reject the null hypothesis. And what is our null hypothesis? The null hypothesis is there is no cointegration, which is none. So we can reject the null hypothesis. And also from here, the probability value is how much? It is very small. So the probability value actually here is how much? The probability value actually here is the probability or p value is actually 0.0009, meaning that 0.09%. And so this is the p value, and when the p value is less than 5%, then we can reject the null hypothesis. That is the normal guideline. What is the normal guideline? If the p value is less than 5%, we can reject the null hypothesis. But if the p value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. So that is the guideline. Okay, then, so meaning that this result and this result actually telling the same thing, that we can reject the null hypothesis. Okay, and our second null hypothesis is at most one. That means there is cointegration among the three variables such as LR, GDP, and M. In other words, there is one cointegrated model, meaning that there is one co-integrated equation. So that is the null hypothesis, and that is this one. Okay, so I check here. You can see from here that trace statistics is 10.4 and critical value is 15.449, meaning that the trace statistics is less than critical value, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that all the variables are co-integrated and there is one co-integrated model or co-integrated model is there. One co-integrated model is there. And what is the guideline? The guideline is if the trace statistics is less than critical value, we should not reject null hypothesis. Rather, we accept null hypothesis. But if the trace statistics is more than critical value, we should reject null hypothesis. And here, for this particular case, at most one, we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that all the three variables are co-integrated. And from the probability value, also the decision is same, because the probability value is how much? From here, the probability value is actually come up is how much? Is 0.001 25.2512, meaning that 25.12%. That is the p-value, and that is more than 5%, meaning that we cannot reject null hypothesis. So meaning that all the variables are co-integrated, right? All the variables are co-integrated, meaning that there is a one co-integrated equation, or one error term. There is one error term, the same meaning. There is a one error term. Okay, so and this is the decision of trace statistics, that variables are co-integrated, right? And there is one error correction term to correct the error. Okay, and then the second method is what? Second method is the, and also it is here, you can see from here, trace test indicates one co-integrated equation at 5% level. The decision is already given here. Okay, so now that we check the second equation, maximum eigenvalue test. So that is the second decision rule. What is that? That is called maximum eigenvalue test, right? So what is the decision of this test? So we can see from here. So here it is the null hypothesis, right? Null hypothesis, and the and the max eigen statistics is more than critical value, meaning that we can reject null hypothesis. And what is the null hypothesis? The null hypothesis is there is no co-integrations. So we can reject this statement because max eigen statistics is more than critical value. And what about here? The probability value, it is less than 5%, meaning that we cannot reject null hypothesis. Rather, we sorry, it is less than 5%, meaning that we can reject null hypothesis. I'm sorry, we can reject null hypothesis because it is less than 5%. So we can reject the none. What is none? There is no co-integrated model. So we can reject it. What is C? C referred to co-integrated model. Okay. Then what about the second hypothesis? At most one. So here we can see the thing, the trace statistics is less than critical value. Less than critical value, meaning that we cannot reject null hypothesis, meaning that all the variables are co-integrated, meaning that there is one co-integrated equation, one co-integrated equation, or there is one error term, Okay, then what about the second one? This one, the probability value. it is 22.06%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that all the variables are co-integrated. Okay, the decision is given here already. You can see from here. Max eigenvalue test statistic indicates one co-integrated equations, meaning that variables are co-integrated. Okay, so what is our decision from the test statistics and max eigen statistics? That decision is our three variables such as GDP, then LR and money supply are co-integrated, meaning that they have long run associationship, meaning that our three variables are co-integrated, meaning that all the variables have long run associationship. All the three variables have long run associationship. Sorry. Long run associationship they have. And here at the below, so here you can see the long run model. That is, the model is here. So it is our long run model, right? You can see from here. It is the dependent variable, right? It is the independent, GDP is the independent variable, and M is the independent variable, and it is the coefficient of GDP, and it is the t value, right? So it is the it is the standard error, right? Standard error, and it is the standard error, and it is the coefficient, right? It is the coefficient, it is standard error, it is the coefficient and standard error. Okay, here you can see, so this is long run coefficient, and this is also long run coefficient, not short run. This is long run coefficient because it is long run model. The whole model is a long run model, not short run. The whole model is a long run model, not short run. So here it is the long run coefficient and long run coefficient. So what is happening here? The sign is plus. The sign is plus, meaning that when the GDP goes up, lending rate also goes up, and when the GDP goes down, lending rate also goes down. So normally it happens. So we are happy about it because normally when GDP goes up, lending rate also goes up. Because when the GDP goes up, meaning that inflation is coming. So the lending rate also goes up. And when the GDP goes down, meaning that economy is not good, so lending rate also goes down. So the sign of the coefficient should be positive, and it is positive here. So we are happy about this model. Okay, then what about the second one, money supply, which is M? So normally when the money supply goes up, lending rate also goes up, and when the money supply goes down, lending rate probably goes down. And here we can see positive sign. So we are happy about it because the sign is positive, and it is following our expectation. The whole model is following our our uh, expectation. That means, so this one is the long run model, and the sign is positive, the coefficient sign is positive, and that is matching our expectation. So we are happy about this model.